Alright, dear children, welcome back to the class. In this video, we'll discuss some of the important questions on the chapter Force and Laws of Motion, and it is the second part. If you haven't watched the first part, you can watch it in the playlist. In that, up to third law of motion, second law of motion numericals are over, and I have given little bit idea about third law of motion. All right, in this video, in this part 2, we'll discuss about this Newton's third law. Then we'll discuss about law of conservation of momentum. All right, so we'll be discussing about this concept law of conservation of momentum. We'll derive the equation, all right, by using that Newton's third law of motion. Then afterwards we'll do some of the numericals. Very few questions are there, but they are very profound, and they have all this importance in your exams. So all these important series videos are there now. These are very helpful for you to prepare for your exam. All right, then moving forward, let us get into the first question. First question is, give any two illustrations. Give any two illustrations for Newton's third law of motion. Third law of motion. To support this Newton third law of motion, they are asking for some examples. The first example, you can give it as rocket propulsion. Okay, rocket propulsion you can give. All right, you know about this rocket propulsion, no, how it happens and all. For example, here is the rocket. All right, so now here what happens, it will leave all this smoke and all, no. So it is this is the floor. On this floor, what is there, this smoke is giving all this action, and on this rocket there will be reaction, that's why it will be profile. So this example you can give. Then rising of a bird. Okay, rising of a bird. So this bird, what it does, it pushes the air down, no, with its wings, and that air will push it above. So that's one example, and you can give the example of swimming also. Correct. Like that you can give examples for this Newton's third law of motion examples. All right, then second question is like this. What is the second question? State and prove. State and prove law of conservation of. Law of conservation of momentum. Momentum by using Newton's third law of motion. Newton's third law of motion. State and prove. You have to state also, and you have to prove it. What is the statement of this? Statement is quite simple, no? Sum of momenta. Momenta means it is the plural form of momentum. Okay, sum of momenta of two bodies. Sum of momenta of two bodies before collision is equal to sum of momenta of those bodies. Sum of momenta of those bodies after collision. All right, so let us try to understand this. What is this? This is like, for example, here is a body of mass m1. It is moving with velocity u1, and there is a body of mass m2 which is moving with velocity u2. All right, so this is having mass m2. Now if u1 is greater than u2, what will happen? Tell me. I am proving it. Now they will collide with each other, no? For example, they are going to collide here. So for example, here is the body with mass m1, here is the body with mass m2. They will collide with each other. Now on colliding, this body m1 is there, no? It will apply some force on body m2. So that force I will call it as F21. All right, F21 means, you understand, no? What is the meaning of this F21? F21 means force on second body due to first body. This is action. And similarly, this m2 is there, no? This will also apply some force on this body m1. So this is called as F12. F12 is means the force on first body due to second body. So this is like action. Okay, so this is like action, And what is this? This is like a reaction. They are equal and opposite. Please remember that. Then after some time t, what will happen? I mean, something has happened between them, this force and all. So this body m1 will move with final velocity v1, and this body m2 will move with final velocity v2. I hope everybody is understanding it, what I'm trying to say here, right? So this is quite simple. Look at this, body m1 is there, which was moving with velocity u1, and body m2 and moving with velocity u2. Now if this u1 is greater than u2, means they are going to collide. So this situation is there, no? This situation is called as before collision. All right, before collision, I mean they haven't collided yet, and this is called as a during collision. During collision, this force and all, it happens. Look at this. During collision, these forces will come into picture, right? Then this situation is called as what? After collision. So these are the three situations we have. Now, what is the sum of momentum before collision? So that is m1 u1, m2 u2. Add them. What is the sum of momentum? Momentum as in moment after collision, m1 v1 plus m2 v2. So what we are supposed to prove? To prove. So we have to prove that according to the law of conservation of momentum, we have to prove m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So we'll try to prove it. Okay. So whatever this is there, we'll prove it. We'll see into this. Now look at this. F21 means you understand, no? So this F2, according to Newton's third law of motion, according to Newton's third law of motion, can we write F21 is equal to minus F12? Of course. Why? Because this F21 and F12 are equal and opposite, no? According to Newton's third law, look at them. So F21 is equal to F12, magnitude wise they are same, but they are opposite, no? So that's why I have written like this, F21 equal to minus F12. Now what is the value of this F21? F21 means it is a force on second body, right? So that's why force means, mass into acceleration and all. So what is the mass of second body? The mass of the second body is m2. What is the acceleration of the second body? We'll see that, and that is equal to minus, and in bracket I'll write F12 means force on first body. So force on first body means, are you understanding? Force on first body means you have to take mass of first body and acceleration of first body, correct? All right, then m2 into, so what is this a2 means acceleration of the second body. Look at the acceleration of the second body. It was moving with velocity u2, its velocity has become v2 in time t. That means how much it becomes? It becomes v2 minus u2 divided by t, correct? Acceleration means a change in velocity divided by time, right? All right, so what is the final velocity of second body? V2. What is the initial velocity? Look at this, u2. So how much time it has taken? T time it has taken. All right, so that's why it becomes v2 minus u2 divided by t, and that is equal to minus in bracket m1. And how about this? I mean, you can put this as square bracket. We are going to get one more bracket there, no? So a1 means it becomes v1 minus u1 divided by t. You know about this also. Look at the first body. What was its initial velocity? u1. What is its final velocity? v1. So what is the time? t. So that's why v1 minus u1 divided by t. So this t, they get cancelled, and afterwards I'm going to have it as m2 v2 minus m2 u2 is equal to let me keep this minus out only. It becomes m1 v1 minus m1 u1, correct? So then afterwards I'm going to have it as m2 v2 minus m2 u2 is equal to minus m1 v1 plus m1 u1, correct? Minus into minus, this minus into this minus is plus. All right, then let me keep this m2 v2 this side only. M2 v2 is here. Let us bring this minus m1 v1 this side. It becomes plus m1 v1, and that is equal to m1 u1. Let it be there, and let me take this minus m2 v2 that side. Then it becomes plus m2 u2. So once you reverse it and write it, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So this was asked for us to prove, no? Look at this, to prove. So this was asked and we have proved it. Okay, so this is the sum of momentum. So this thing, sum of momentum before collision and this is sum of momentum after collision, and both of them are equal to each other. So this was the proof of law of conservation of momentum by using Newton's third law of motion. All right, so let us look into third question. What is this third question? A bullet of mass 200 gram is fired from a gun of mass 5 kg. All right, if velocity of the bullet is 50 meter per second, find recoiling velocity of the gun. All right, I mean, this is dependent on law of conservation of momentum only. So let me take this. What is that? Mass of the bullet. Let me take mass of the bullet as mb. Mb is equal to 200 gram. 200 gram means it is going to be 200 divided by 1000. So that will be 0, 0, 0, 0. That will be cancelled, and it is 0.2 kg. So mass of the bullet is 0.2 kg. It is fired from a gun of mass 5 kg. That means mg means mass of the gun, that is equal to 5 kg. All right, if velocity of the bullet is 50 meter per second, that means initial velocity, I mean, we don't know whether initial velocity we take it as 0, so usually we take it as vb means velocity of the bullet, so that is going to be 50 meter per second. Now they are asking about this recoiling velocity of the gun, that is equal to question mark. All right, let us try to analyze this. Now for example, let me draw a gun here. So this is the schematic diagram of a gun. So I mean, in this gun there is a bullet. Okay, now once you trigger this, what will happen? This bullet will move forward. No, it will move forward with some velocity. All right, what was its initial velocity inside? The initial velocity of this bullet was 0. And what was the initial velocity of the gun? 0. All right, and the mass and all they are given. Now this bullet is there, no, so it will start to move outside. So velocity of the bullet is like what is that? It is given it as 50 meter per second. Once the bullet moves forward, this gun will recoil back. I mean, it will move back with some velocity, so that is only called as recoiling velocity, and they're asking about this. All right, now I mean, how to solve this? According to law of conservation of momentum, according to law of conservation of momentum, what we are going to say? We are going to say sum of momentum before collision. So what is the momentum of the bullet before the collision? I mean, mass of the bullet into initial velocity of the bullet. So this is the momentum of the bullet, plus what is the momentum of the gun? So mass of the gun into initial velocity of the gun. Are you understanding? So definitely this will be 0. Why it is 0? Because a bullet and gun both were in rest, no, so that's why these become 0. So total it becomes 0. All right, then afterwards mass of the bullet remains same. Final velocity of the bullet is vb, plus mass of the gun mg, and final velocity of the gun is vg. Is it clear? Try to understand this. We did know, so m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, the same thing, but here m1 is replaced by mb means mass of the bullet, and m2 is replaced by mg means what? I mean, that is mass of the gun. So they are replaced by these two things. All right, everything else is same, there is no change here. Okay, all things are same, only a few, I mean, adjustments have been made. Now let us try to understand this. mb means mass of the bullet. Mass of the bullet is 0.2 kg, right? So it becomes 0.2 into 0, because initial velocity of the bullet is 0, plus mass of the gun is 5 kg, and then into 0, and mass of the bullet is again 0.2 kg into, and what is the velocity of the bullet? So that is like 50, plus what is the mass of the gun? Mass of the gun is 5 kg into vg, we don't know, that's what we are supposed to calculate. Now this LHS completely it becomes 0, and that is equal to 0.2 into 50 is like 2 into 50 100, and 1 place comes back, that's why 10, plus 5 vg. All right, so let us bring this 5 vg this side, it becomes minus 5 vg because 0 is there, and that is equal to 10. I mean, then I'm going to have vg is equal to 10 divided by minus 5. 5 ones are 5 twos are. So that's why velocity of the gun is going to be minus 2 meter per second. So this is the velocity of the gun. I hope everybody understood this problem. See, the trick is first you have to take the total momentum 0. Afterwards you have to add that momentum, and both you have to make it as, why it has come as minus? Because this gun is coming back, no? So if going forward is positive velocity means, then reverting back, recoiling back is taken to be negative. All right, so this was the solution for this problem. Now let us look at this fourth problem. What is this fourth problem? Two footballers of mass 60 kg and 60 kg and 80 kg 60 kg and 80 kg are approaching each other with the speeds 18 kilometer per hour and 9 kilometer per hour respectively. Okay, they are coming to each other. They collide and stuck together. Find their velocity and mention in which direction do they move. Okay, so let us look at this question. Now one football player is there. Let me call this as football player A. Okay, so if you call the football player A, so his mass ma is equal to how much it becomes? It becomes 60 kg. And there is one more football player, let me call him as B. So his mass becomes mb. So mb is equal to how much it becomes? It becomes 80 kg. Now they are approaching each other. Okay, so they are approaching each other. Now they come here, come to a point here, and they collide. Okay, they collided here. So let me show it here. They got collided here at this point. Now this person and this person, they got collided. Now they are stuck together each other. Their hands are maybe winded up. Now in which direction they will move? With what velocity they will move? Let us assume they will move with some velocity v. Okay, their final velocity of A and final velocity of B, both are same, no? It is equal to v. Initially, with how much velocity this person is moving? Look at this. 18 kilometer per hour and 9 kilometer per hour. So this person, he was moving with how much velocity? uv, right? So uv, he was moving with how much velocity? He was moving with velocity of 18 kilometer per hour. And how about this person? This person was moving with velocity ub, that is equal to 9 km per hour, and they collide and they start to move at same velocity. Why they start to move at same velocity? Because they got stuck together. So that's why you can apply here. What you can apply? According to law of conservation of momentum. So according to law of conservation of momentum, what you can say? You can say momenta, sum of momenta before collision is equal to sum of momenta after collision. Now what is the momentum of the person A before collision? That is ma ua, correct? Plus what is the momentum of this person B before collision? That is mb ub, correct? And that is equal to sum of the momenta of the bodies after collision. After collision, what is the person A has momentum? So that is like ma va, plus what is the momentum of the person B? mb vb. I hope you are understanding what I am trying to say. All right, so you can substitute the value now. What is the value of ma? That is 60 into 18, plus what is mb? That is 80 into 9. Now one more thing. Now here you have to be very careful while substituting this. Now this velocity, if you have taken plus 18, means this you have to take it as minus or not. Very important, dear children, because they are approaching it in a different direction, no? So this has to be taken as what? Minus 9 km per hour. clear? So that's why while substituting also you should be very careful. So you have to substitute as a -9, then only you'll get which direction they will move. I mean, both you are mentioning this also plus and this also plus means they are moving in the same direction. So I mean, that is not the situation given, no? They are moving in opposite direction. I mean, they are approaching each other. So that's why minus you have to take. So that's what I have substituted minus here. And what is the value of MA again? 60 into VA means V is there. Plus MB means 80 into VB means again V is there. So let us try to do this. I mean, 6 8s are 48, 4 is the carry, and 108 and 1088 becomes then afterwards minus 8 9s are 72 minus 728 becomes, then it becomes 60V plus 80V. All right, then I'm going to get this as 0 minus 0 0, 8 minus 2 is 6, and 10 minus 7 is 3, 1 is the carry 0, 360, correct, no? So it becomes 360, and that is equal to how much it becomes? It becomes 140V. All right, so then I'm going to have this V is equal to how much is that? 360 divided by 140. These are the basic calculations which you can do. 0 0 got cancelled, and you can do it as a 2 7s are, and 2 18s are, then 7 1s are, then 7 2s are 14, then 4 is the carry, then 7 5s are, right? 7 5s are 35. So you got this value as V is equal to 2.5. So approximately 2.5 kilometer per hour. Now you tell me this is the final velocity of both of them. So with this much velocity they move with 2.5 kilometer per hour. Now the direction is very important, in which direction they will move. Now look at this. Now this value, so whatever this value is there, we got it as positive, no? So once we have got the positive means, so this direction we have taken it as positive, this direction, look at this direction we have taken positive means, so both of them will move in this direction, like towards right only. All right, along with B, I mean along the direction of B, I mean they will move like this, direction of B. This was a direction of, not B, direction of A, right? So this is the direction of A, right? Along the direction of A or opposite to the direction of B they will move. I hope you are understanding what I am trying to say. So they are moving in this direction. If we would have got the answer, this final velocity as a minus means, so what would have said? Would have said like they will move along the direction of B, or along the opposite to the direction of A, would have mentioned like that. But right now we have got positive means we have to mention they move along the direction of A. All right, so what I am going to write, they move along the direction of, A. Okay, that football player A. I hope you understood it. This is quite a simple question, but you have to make simple approaches to get this. I mean, this law of conservation of momentum is there, no? So this has to be applied properly to get these answers. All right, let us see one more question to understand this. Now from this question definitely you are going to understand this. Now this fifth question, a coconut of mass 4 kg splits into two pieces, each of mass 1 kg and 3 kg. Okay, if 3 kg part moves with velocity of 2 meter per second, find velocity of the other piece or other part. Okay, now there is a coconut. Okay, so here is the coconut, and what is the mass of this coconut? I mean 4 kg. Now this splits into two pieces. For example, it got split. Now one is 1 kg, another is 3 kg. Now this piece is like 1 kg and this is like 3 kg. It will move with some velocity, correct, no? So let me call m1 is equal to 1 kg and m2 is equal to 3 kg. What were their initial velocities? Initial velocities were 0, no? Why they were 0? Because they were inside this coconut. I mean, they were not moving, so that's why initial velocities are 0. Now they have mentioned if mass, if 3 kg part moves with a velocity of 2 meter per second, that means it starts to move with 2 meter per second. We have called it as m2, no? So let me call it as v2. It has started to move with velocity 2 meter per second. Now they are asking this v1 equal to question mark. This v1 you must get negative. Why? Because coconut pieces won't move in the same direction. If one is moving in this direction, the other will be in the opposite direction. I hope you are understanding. All right, so v2 is given here. So what is the value of v2? The value of v2 is 2 meter per second. Now they are asking for the velocity of first part. Correct, no? All right, so this why I called it as v1, because I have taken its mass as m1. Why I have called this as v2? Because I have taken its mass as v2. All right, now according to law of conservation of according to law of conservation of momentum. So what does law of conservation of momentum says? It says m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So this total answer, this becomes 0. Why it becomes 0? Because both of them are at rest only, so that's why. So m1 is like 1 kg into v1 we don't know, plus m2 is 3 kg, and v2, what is the value of v2? v2 is 2 meter per second. All right, then 0 is equal to, it becomes 1 into v1 is v1 plus 6 it becomes. Correct, no? All right, are you understanding my point? Then afterwards, I mean, you keep that v1 there only and send this 6 this side, so 0 minus 6. So then it becomes v1 is equal to minus 6 meter per second. I told you, no, you will get this as minus. All right, so why it is minus? Because it is moving in the opposite direction. And one more thing you can observe, this is minus 6 meter per second. This is minus 6 meter per second. This is more and this is less. Why? Because this is a bigger piece. No, look at this 3 kg. This is a bigger piece. So that's why it will move with low velocity. And this is smaller one. So 1 kg means, don't you think it is smaller one? So it is smaller one. So that's why it will move with more velocity. So when you break a coconut, larger piece will remain there only, but smaller pieces will go away, no? So like that. All right. So applying this law of conservation of momentum. So whatever this law of conservation of momentum is there, applying this formula according to the situation, you have to find in which situation you have to take plus, minus and all. So if you apply this, then you should be able to solve all the numericals. All right, dear children, thank you very much for watching this video. Whichever chapter is there in your physics and mathematics, those videos will be uploaded. Don't forget to like the video, yes, and share this good work with everyone else, and comment on the video how did you feel about it, and please don't forget to subscribe so that the good work will be reaching maximum number of students. All right, then, thank you very much for watching this video. Have a good day. Bye bye.